Hello guys, and welcome back to the channel. In this video I'm gonna build a new server. Hopefully, if everything goes as planned, this is gonna be a 10 HDD server. It's gonna run Storj. I don't care about the speeds of the hard drives, they don't have to be fast. I don't care about redundancy, as Storj has already this built in. And if everything goes as planned, it's gonna be running on this little board, a Raspberry Pi 5. 10 hard drives on a Raspberry Pi 5. Something I've never done before, and I don't even know if it's possible, but I'm gonna attempt. So, in this video, I'm gonna show you what parts I'm using to build this and how I'm gonna set it all up. Thank you for watching. Alright, so to achieve this with 10 hard drives and a Raspberry Pi 5, I'm gonna be utilizing the Raspberry Pi's PCIe connector that is sitting right here. And I bought a product from Geekworm that's hopefully gonna help me achieve this. So I haven't opened it yet, but I'm gonna go ahead and do it now. So we have some screws and some mounting cables, PCIe cables, sorry. So what's in here is a very special product. Now, I'm gonna show you what it can do. Alright, so this little board right here is gonna allow me to connect it to PCIe with the cable to the Raspberry Pi PCIe. It's also gonna allow me to power this board and the Raspberry Pi with a normal ATX power supply. As you can see here, it says power in Molex and it has 12 volts. What it's also gonna allow me to do is use PCIe 4X. So that means, in theory, if I can get everything working, with a single ATX power supply, I can power Raspberry Pi and insert one of these boards, which is a 10 SATA card, 10 times SATA card. You can see these little notches right here, right there, and right there. If you look at from the side, you can kind of see, if I can get it to focus, the notches right here, they're kind of springy. I'm not sure if you can see this, but they kind of spring in. This is the power that is delivered from either this one or this one. I'm gonna use this one because I have an HDD power supply for this project. And it's gonna match up with the power input on the Raspberry Pi's USB-C. Now, if you buy this product, please keep in mind, do not power these two at the same time. Only choose one. So only power this one or only power this one. And since this one uses PCIe, you need to power this one. So no USB-C has to go in here. Now I'm gonna go ahead and try to do some testing just to see if I can get everything working with the Pi image and so. And then I'm gonna show you how I'm gonna build this server. Alright, so I just went ahead and mounted the Raspberry Pi to the board and inserted the stand-ups that are here. Now be a little bit careful with the PCIe connector. You do get two in case you break one, but just be very careful because it kind of has to bend from the inside in here all the way over to here. But it should work fine. I'm gonna go ahead and try to put some power on the board now to see if the Raspberry Pi starts up. After that, I will be installing an image, Raspberry Pi image to an SSD that I will be connecting to this machine. Alright, so I went ahead and wired up a on and off connector on the power supply. The power supply I'm going to be using is a Seasonic G12 gold rated. It's one that I have in spare. It's 650 watts and it should be plenty fine for this setup. This is the first time that I'm turning on the switch, so let's see if the Raspberry Pi lights up. Alright, look at that. We got a green light. It powers up. And that's a really good sign. Very nice. Now I'm going to power it down and I'm going to install a Raspberry Pi image and then we will have to see if it actually also boots up. So be right back. Alright, so I have this NVMe SSD to USB enclosure that I'm going to be using for the OS drive. It's quite simple. That will be OS drive, and then I'll use this SSD as a caching drive for logs and database files for the Storj nodes. I salvaged this old USB controller from an external hard drive and saved it, and now it's proven useful because this allows me to just connect straight up USB, which this will be great for keeping the logs and the database files off of the hard drive so they can perform better. So I'm gonna flash this, assemble this right here, flash it with Raspberry Pi image, and then I'm gonna boot up the Raspberry Pi and I'll see you in a minute. Alright, so Raspberry Pi OS is being flashed to the SSD right now. So right after that's done, I'm gonna go ahead and boot up the Pi, get it to a monitor and a keyboard so we can go ahead with the next steps. Alright, so the Raspberry Pi is all hooked up. We got a flashed OS, we got a USB, we got keyboards, we got HDMI, and we got power. So when I switch this on, this screen right here should light up with the Pi OS. Let's give it a go. Okay, so the disk is flashing, which is a good sign. The Pi is flashing green, and we got an OS. Very nice. Alright, so because we're using a power source that is different from the USB-C original charger, it will give us this warning about 5 volt, 5 amp power supply. I don't think it's a problem because I do actually think that we can draw enough power from the Heatsinks power supply. So I am going to disable this check in the config.txt. We don't have to do that now. What we can do now is we can just press the power button to temporarily enable this flag, and that way we can boot with USB. This is a safety feature because normally USB will not have enough power to be able to actually boot off a disk with a smaller power supply, but we have a big enough power supply that it should not be a problem. So I'm going to press the power button right now. There we go. So it took a little while. I think it was in the wrong state to begin with when I pressed it, but it is working now. We are now booting up to the desktop. Alright, so the Raspberry Pi has been set up. It has Ethernet and password and username and stuff like that. I just went ahead and decided to update it, so I'm going to go ahead and do that right now. You can do it with the command, but it's easy to just press here. This will definitely take a while, so I'm going to go ahead and skip it. Alright, so after updating the Raspberry Pi, I went ahead and installed the Sata expander card into the PCIe slot on the Geekworm card. I then hooked up a 1 terabyte disk just for testing. I'm not going to be using this disk for the server, but this is just for testing. I don't know if drivers are needed or any kernel updates has to be done to the Raspberry Pi OS. That is what I'm testing. That's also why this whole video is just an experiment and a fun thing to do. It's probably not your best bet to build an economically viable server, but this is fun for me. It didn't cost me much because I already had most of the parts laying around, and I think it's a lot of fun to tinker with. I'm gonna go ahead and press the power on button now, and hopefully this hard disk should spin up, and maybe we'll be able to see it in the Raspberry Pi OS. I'm not sure if you can hear this, but we definitely have a spinning hard disk, so it's gonna be interesting to see if we are able to actually boot up and see it in the OS itself. I just have to press the power button. I haven't altered the config yet, but I'm definitely going to do that. Okay, so the Raspberry Pi is completely booted up, and I will be able to just have a quick look in the OS. The disk is spinning, so I'm going to have a look and I'll see if it's available to reach. Alright, a small update after setting up the Raspberry Pi and plugging everything in. I was not able to detect the hard drive in the OS. Turns out I didn't read the documentation of the Geekworm board correctly. You actually have to keep the PCIe cable. You have to put it in the right way. You can put it in the wrong way. One side needs to go to Raspberry Pi and one side needs to go to the board. I had flipped it, so now I flipped it back and now it's correctly inserted, and I will just show you an update. Alright, so now there's actually a light within this board right here. The disk is spinning. I am getting these messages right here. I'm gonna go ahead and figure out what that means. I'm not sure what I should be thinking about this. Maybe I need to do some configuration. I'll have a look. But maybe there is a hope forward. It's definitely better than it was before. So I'm gonna do some more investigation and I'll have a look on how to set this up. Also, referring to the documentation, you can see here that you need to actually put the connector in the right way. But what you also need to do is set up some config stuff within the Pi software itself. So please keep that in mind if you go ahead and buy this board. Alright, so after quite some debugging and Google searching and some ChatGPT stuff, I came across a miracle. So the PCIe device would not work. I wasn't able to figure it out on my own. And I don't know if you know the YouTuber Jeff Gerling. Awesome YouTuber. He commented on one of my videos, by the way. I was so proud. I just found a GitHub post that is 2 days since last activity where Gerling himself actually came up with a solution, and it freaking worked. I'm about to show you. This could not have come at a better time. The timing for me is perfect. I'm in so luck. I'm gonna show you how this is done, and it's actually quite simple. Alright, so as you can see, Girling did post some stuff on GitHub. There is 2 different threads that is perfectly good, but this one, specifically 2 days old, said here that to change these or add these lines in the boot firmware config.txt. I did that. I also did the config stuff that I was having to do from the Geekworm board. This is amazing, and it's so nice. Girling, if you are watching this video, thank you so much. Like, amazing help. You just saved me hours. Even though I spent some hours on this already, you saved me many more. I was able to boot the Pi up. As you can see right now, we have a 1 terabyte SDB drive that is sitting right here, connected to the PCIe card in the PCIe slot, and it's working fully. This is so nice. I'm very, very happy about this. So just like that, we got some of the hardware up and running. Now, this was just the testing phase. What I'm gonna go ahead and do now is actually I'm gonna assemble the whole server. I have a whole build plan for this with hard drive mounting and stuff like that. And then I'm of course gonna set up all the 10 drives and then get them configured and hopefully see if they show up in the OS. I'm also gonna be attempting a speed test, running speed test on all of them at the same time, just to see what kind of speeds we get. I don't think they will be high, but they don't need to. This is a simple storage server for Storj, and they don't need to have high speeds. So I'm gonna just cut the video here, and you will see in the next part. Quick update, I just did a normal read test on the 1 terabyte disk to see what kind of throughput I would get from PCIe card. It is PCIe 2.0 X1, which means if my calculations are correct, I have about 500 megabytes of bandwidth available per second, and divided by 10 hard drives and counting for overhead and stuff, I should be about 40 megabytes per second on the hard drives, which should be plenty for Storj. It's fine. And I'll just show you the speed test that I just did on one drive. So as you can see right here, we got about disk reads of 196 megabytes per second. So that is probably within the specs of this kind of hard drive right here. I don't think that speed will be a problem, but I am going to make a speed test with all 10 drives once they are connected, just to see what kind of speeds we're looking at. All right, so I just received these plates from Amazon, and they are made for hard disks, and I can screw in 8 hard disks on each of these, which I'm going to use for the build of the storage server. So I'm going to go ahead and assemble this and put 8 hard drives in here, and we'll see how it turns out. All right, so I just got assembled the 8-tower hard disk thing from Amazon. We got 8 drives here. We got 2 small fans that can push some air through, hopefully to keep it cold. And then we have this side here with all of the SATA and power connections, which is great. And then I got 2 drives here in like a drive cage I hooked off from an old desktop computer. So that's gonna be great. Now I'm gonna find some kind of place to mount this and this too. And then of course we have the Raspberry Pi here with the board, and that's gonna be mounted somewhere as well with our PCIe to SATA board. So I'm gonna find, I think, some wooden plate that I'm gonna mount everything on to actually keep it nice and tidy. And then of course we also need to make space for the power supply, but stay tuned for that. All right, so a bit of progress here. I went ahead and found this wooden piece here that I can use to mount everything on. I'm going to be mounting the power supply with some metal holders. I'm gonna be bolting this on, I'm gonna be bolting this on, and then I'm gonna make a mount for this. And I also have a piece of metal that should be able to line up quite perfectly with this one right here. So everything is supported. I just went ahead and wired up some stuff just to see how everything fits. But I actually think this is going to be quite a great fit. So what I'm gonna go ahead and do now is I'm gonna go ahead and mount up everything the way that I want it and screw it in, and then I'll see you then. All right, so the server is starting to look like something. It looks like an absolute monstrosity. We got some fans, we got some disks. We even got a little fan controller that you can control. We have 8 disks right here. Then we have 2 12 terabyte disks right here. Fan on it, of course. We got the Raspberry Pi. I put some small heatsinks on. I might order a fan for the Raspberry Pi. Then we have the Sata controller that is absolutely fully hooked up. I am gonna buy at some point a small fan to put on the heatsink here because that can get hot. So I'm gonna do that before I actually get the server like fully up and running. I am gonna tidy up the cables. I'm gonna tidy up these cables. I need to put a power switch on the PSU so I can keep it running. But other than that, it's actually looking quite great. This is mounted firmly. This is mounted firmly. And this is mounted firmly. So is this one. So I haven't booted up yet, but what I'm gonna go do is I'm gonna tidy up everything and then I'm gonna go ahead and boot it up and see if we can get it running. Okay, so I went and hooked up USB, power, and the OS drive. I have put a HDMI cable in and I have tidied up some of the cables. We got a little bit of zip-tied cables here. We got a bundle up here that's not gonna be used. If I press this switch now, everything should turn on. I haven't tested it yet, so this is moment of truth. I really hope that everything spins up. I hope that we can boot to the Raspberry Pi OS. But most of all, I hope that all 10 drives are detected in the operating system. First, let's go ahead and give it a go. Okay, we got sound. Do we not have any spinning? Oh, there we go. I think there might be a loose connection with the old fan hub. We might have to look into that. Oh, we got some lights in the controller, as you can see. We also have a screen that is lighting up, but doing nothing right now. I'm very excited. Oh, look what we got here. Come on, boot up. Oh yes, we got a boot. Let's see what we can find in here. Departed. Then we need a password. Come on. Okay. It's loading stuff. I think we might be good. Okay, yeah, we are good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 disks, including the OS drive. Guys, that is amazing. That is amazing. So I think next step is, of course, we're also gonna add a caching SSD, but that's not yet. And then I also need to set up the Storj nodes. Also not yet. It's been a long day. But so far, so good. This is so far looking great. One thing I can do is I can just power it down and then we can go ahead and see what kind of power draw we'll get. So give me a second and we'll have a look at that. All right, when I turn on the power, we should be able to see some power draw. 130, 150, 140, 129. Now keep in mind, we have 10 disks, that's quite a lot here. 81, 83. It's still booting, so let's wait and see. Okay, we are in the OS. So about 85 watts continuous power draw. That's pretty good, I think. And keep in mind that when the disks fill up, I can always increase the size and the power draw should stay roughly the same. All right, I will move on to next phase. All right, so the Raspberry Pi is running. It's been running for a couple of days. No Storj nodes on it yet. All the disks are doing fine, temperature-wise and connection-wise. I did run a speed test, running all 10 disks at the same time, and I'm going to show you the results. They were not surprising to me, and I think they will be fine. I don't need fast disks, and I think that with a Storj load, it's not going to be a constant load. So I think it'll work out fine. Of course, I'll have to wait and see. But I'm going to show you the test results right now that I just made. All right, so as you can see here, I made a small FIFO test that just ran. This is the table of speed. Now you can see some of these have really great speed, like 27 megabyte seconds stuff, and some of these are really slow. I think the reason that they're slow is simply because of the bandwidth that the other ones are taking, and we just cannot push that much bandwidth through the controller because it's old PCIe. So if you look, for example, at SDH, I ran that test again for only this disk at a time, and I actually got a way better result. So it was like 10 megabits per second, something like that, which is fine. That's gonna be okay. So I think these speeds will be better when I run Storj, because Storj is not gonna be constantly putting 26 megabit on one of the drives. So what is left now is to set up the Storj nodes, and then I will update you again. Alright, so as you can see, a node is now up and running on the Raspberry Pi. I'm gonna go ahead and set up all the others, but overall, I think this project has been a success. If there is any updates with it, I will post a new video, but this is it for now. As you can see, we are getting data from the storage node, and everything seems to be working just like it should. Thank you guys so much for watching. I hope you enjoyed it, and if you want to see more content like this or updates on this server, go ahead and give me a subscribe. Have a great day. Goodbye.